F, since there is only one atom, so there is no need of writing sigma here, because we are not making summation, only one atom is there. Fj is the atomic scattering factor for that particular atom. Keep in mind, if I change the atom, this thing will change. For example, if I use sodium, sodium has only 11 electrons in its outermost shell, it will have a smaller value of F. And if I take gold, it has 79 electrons, so it will have a bigger value of. So this F depends what type of the atom is present. Now, this factor defines where the atoms are present, So I can write it as Fj e raised to the power iota 2 pi h into x dash xj plus k into yj plus l into zj. Now, h, k and l are the indices of the plane, and x, y, z are the coordinates of the atom, where the atom is present. And since I know in this case the x coordinate of the atom is 0, the y coordinate of the atom is 0, and the z coordinate of the atom is also 0. So what I write, e raised to the power iota 2 pi h into 0 x plus k into 0, which is y, plus l into 0, which is z. And if you calculate, it will come out to be f e raised to the power 0. And f e raised to the power 0 is anything raised to the power 0 is always 1. So we write f multiplied by 1 is equal to f. Okay? Now you can see from this equation, whatever the values of x, y and z, this term will always be e raised to the power 0. Okay? For any value of h, k and l, this term will always come as 0. So what I can say, that all values of h, all values of k, all values of l, or in other words, all planes which are representing h, k, l are the diffracting planes in this case, which case? In case of the primitive cell, which can be simple cubic or which can be any other. If I want to find the intensity, so I will scale this F value. I is equal to F square is equal to, which is F square. F is independent of the scattering plane. It means all reflections from any plane are present in case of simple cubic lattice, or simple cubic, or simple any other type of the lattice, simple tetragonal, etc., etc. All planes are present. Next thing is, I take body-centered position. Body-centered position. You can see, base-centered position. Atom is present at the base, atom is present at the top base, and atoms are present on the corners. Okay, this is contributing half towards this cell, this is contributing half towards this cell, corner atoms are contributing 1 by 8, so total number of atoms will be 1 contribution from the corner and 1 contribution from the this base and top. So I will write the coordinate of this will be 0, 0, 0, and the coordinate of this will be 1 by 2 x, 1 by 2 y, and no 0. I can take only these two atoms. This one has a coordinate of x, y, z as 0, 0, and 0. Where this one has a coordinate of x, y, z as 1 by 2, 1 by 2, and 0. You can see here, I can go to this atom by taking half step along x-axis half step along y-axis and no step along z-axis. I will neglect other atoms because this unit cell just contains 2 atoms. So I will use the same equation here, but I will use the coordinates of both atoms. So f I can write as fj e raised to the power iota phi j, fj e raised to the power iota 2 pi, h into xj plus k into yj plus l into zj. Put the value of x for x, y, and z for the first atom. This is 0, first atom. This is 0, y, first atom. This is 0, y for the first atom. And then plus, because I am using a sigma. So this is e raised to the power 2 pi h, coordinate of this atom, first coordinate 1 by 2, plus k, coordinate of the y1 1 by 2, plus l into 0, this one. So I have substituted this value here. And if I calculate, this will be f e raised, just like the previous one, e raised to the power 0 plus f into e raised to the power 2 pi h into 2 pi h divided by 2 plus k divided by 2 plus 0. So I can write h plus k divided by 2 multiplied to 2 will be cancelled with this. So I will get f is common. I can write e raised to the power 0 is 1 plus e raised to the power iota pi h plus k. Okay? Now, what value h plus k will be there to get the reflection as this one? For example, if I write h plus k even, h plus k even. So this number will be e raised to the power even into pi. And already we have done e raised to the power even into pi is equal to 1. So we should multiply it by f. So we will get f from here and f from here is equal to 2f. Okay, and if I find the intensity of these h-scale planes, reflection of the h-scale planes, f scale is equal to 4f scale of this. However, if I substitute the value of h and k, h plus k is odd, h plus k in odd, so what I will get, this number will be f, this number will be f, and this number will be minus f. So f minus f will be equal to 0. So such planes in which h plus k is odd will not show you any diffraction in the diffraction pattern. Such planes in which h plus k is even, that will show you the intensity in the diffraction pattern. Now f is independent of L. You can see there is no L appearing in this case. So it is independent of L. So what I can write, these planes will show you the diffraction, and you can see h plus k, this is h and this is k, adding them 0, 0 is always taken as even, so this is allowed. 1 plus 1, again even, this will be allowed. 1 plus 1, again even, this will be allowed. 0 plus 2, again even, this will be allowed. 0 plus 2, it will be allowed. 0 plus 2, this will be allowed. And any value of L can be there. So these planes will appear in the diffraction pattern, where these planes, 1, 0, 0, in which 1 plus 0, h plus k, is odd, 1 plus 0 is odd, 1 plus 0 is odd, 0 plus 3 is odd, 0 plus 3 is odd, 0 plus 3 is odd. They will give you negative f value, and f is equal to 0, that is the structure factor will be equal to 0. These planes will not appear in the diffraction pattern. These planes will not be appearing in the diffraction pattern. So if you take a material with this structure, you take a material with this structure and throw X-ray on it, these planes will show you the diffraction pattern, and these planes will not show you the diffraction pattern because of the geometry of this particular, I will say, the structure, which we call as base-centered or C-centered orthorhombic. Orthorhombic means A is not equal to B, is not equal to C. But alpha is equal to beta is equal to gamma is equal to 90 degrees. So this will appear, such reflection will appear and other will not appear in the diffraction pattern. Take it. Stop it.